In our previous lesson, we have looked at using the method of completing the square to look at algebraically finding the roots of quadratic equations. We've gone through the process where we use the as squared plus bs plus c, and then algebraically we went through the process to be able to look at it. My name is Nana Ewedu, and you can call me Sir Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to look at how we can solve a quadratic equation using the method of completing the square. And we want to consider an example. Let's look at the example. So the example says that using method of completing the square, find the roots of the equation, right? So when we talk about the roots of the equation, we are only looking at an answer to a quadratic equation, right? So the equation given is x squared minus 6x plus 7 is equal to 0. Now let's look at how we can solve the roots of the quadratic equation by using method of completing the square specifically. So the equation given is x squared, right, minus 6s plus 7 is equal to 0. So the first step we say is that we must check whether the coefficient of the s square is 1. If it is not 1, we divide through by the coefficient. In this case, it's 1. Right, so we move the constant term across the equal sign, so we get x squared minus 6s is equal to negative 7. Right, so the next step is to take the negative 6, right, multiply it by half. So we are always multiplying the coefficient of the x together with the sign attached to it by half. Right, it's something that we must always do. Right, so when we multiply negative 6 times half, it should give us negative 3. Then we square the negative 3 and add it to both sides of the equation. So we are going to have x squared minus 6x, right, plus minus 3 all squared is equal to negative 7 plus minus 3 all squared. Right, so we'll look at the reason why when we get to this side, we write the equation, right? We take the s term of the equation, which is x, right? And then we take what's in the bracket minus 3 and then we square it, right? So when we take this, for instance, let's do this aside. So when we take x minus 3 all squared, right, we can square this or we can expand this, right, and have x minus 3, right, and x minus 3. So x multiplying x gives us s squared, right, and then minus 3 multiplying x gives us minus 3x, right, and then we are going to have minus 3 multiplying s giving us another minus 3x, then minus 3 gives us plus 9, right, or better still, we can take the first one, which is x, and multiply by x minus 3, then minus 3 and multiply by x minus 3. That expansion is what we get here. So x multiplying x gives us s squared, x multiplying minus 3 gives us minus 3x, right, minus 3 multiplying x gives us minus 3x, and the negative gives us positive. So we see that we get x squared minus 6s plus 9 when we expand this, and it's the same as what we see here. So s squared is here, right, and then minus 6x is here. Negative 3 all squared gives us positive 9. So it means that when we expand this x minus 3 all squared, we should get s squared minus 6s plus to bracket negative 3 all squared. That's why when we get here, we take the x term, we take what is in the bracket, and then we square it, right? So that is what we see here, right? When we expand what we get, we are able to get, right, s squared minus 6s, right, all into brackets plus all into bracket minus 3 all squared. So for the other side of the equation, we are going to have minus 7. Negative 3 all squared will give us what? Positive 9. Right, so we are going to have x minus 3 all squared to be equal to negative 7 plus 9 is going to give us 2, right? So from here, what we are going to do is that we are going to find the square root of both sides. So the square root will cancel the square root of x minus 3, and that is equal to square root of 2, right? and we know that the square root of 2 is positive and negative. So it means that x is equal to 3 plus or minus square root of 2. And therefore, x will be equal to 3 plus square root of 2 or 3 minus square root of 2. Right, so you can leave your answer like this, or you can also decide that you go through finding the square root of 2 and then add it to 3 so that you can get the decimal form of it. So you are going to have, right, square root of 3 or 3 plus square root of 2, right, to be equal to, right, so 3 plus square root of 2 will be equal to, in decimal form, 4.4142, right? So we can say that S can be equal to 4.4142, right? Or you are going to have 3 minus, right, square root of 2, and that gives us 1.5858, right? So 1.5858. So this is a process we go through when we are solving the method of completing the square. It is the same process we did when we were going through the algebra. So first and foremost, we ensure that the coefficient of x squared is 1, and then we move the constant term across the equal sign, right? Then the rest of the equations are just manipulations. So we take the coefficient of x multiplied by half, and then we add the results, we square the results and add it to both sides of the equation. And then once you're able to do that, the rest is to simplify, right, and find x. So we're going through the process of using method of completing the square to be able to actually solve a quadratic equation. In our next lesson, we want to also look at another example of solving quadratic equation using method of completing the square. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.